Let's get some electric work done. All right, first we'll see that we have access to the back of our electric panel. That is excellent. So we can see all the wires going up, some coming down out of the bottom. You got the service entry wire from the meter coming in right here, and it tracks up over and in. So a lot of this is the older style cloth sheathed wire that was the precursor to Romex, which isn't unsafe, but it's not something I like to mess with. I'll show you why I don't care too much for this wire. First, let's take a look here. We've got positives and neutrals, or hots and neutrals. Can you tell which one is which? Got to really get down there and look. See which one should be the black wire, which one should be the white wire. Also, this cloth wrap is kind of brittle. It can break off over time. Same here. This gets brittle. I much prefer the modern Romex. So I'm going to cut all this out that's visible at least, swap it out for the good Romex stuff. So here's the wire that I'll be using for my electric outlet circuits. It is yellow sheathed 12 gauge Romex. It has black, white, and ground. And this can carry a 20 amp circuit. So most of the outlets and appliances will need 20 amps. So we're just going to run this to be safe. I'm going to be running new circuits in the kitchen. They will all obviously start here at the panel. One will connect here and have two outlets for whatever appliances need to go on this countertop here. The two appliances there. There's going to be one here for a vent hood. There's going to be a wire that runs down here for the oven. And then off of this, we're going to come down and around here, through that stud, through that stud, through that stud, and mount a box down here in case somebody wants to turn this into an office sort of area, or even have just a plug there since there's nothing on that back wall. There's actually not one around until about right there. So we want to get some extra outlets here. So we'll run that on one circuit. Next circuit is going to be off of there, dedicated for the fridge. So that's going to run all the way down here, mount it down here so the fridge can plug in. I'm going to take that one out. Then we're going to come up and over to here where we have a 3-gang box. One will be a light switch for the living room. That'll be a 3-way with the one over there. We're going to have another 3-way switch here that lands over there as well for the kitchen lights. And then we're going to have one right there that controls the two lights that will hang here. So we'll be running wires there up into the attic to form the 3-way switches. We're going to replace that box over there with a 3-gang box so it can control kitchen, living room, and outdoor. We're going to run lighting wires here and here. We're going to land both of those 3-way switches in a box somewhere here that I can then run a circuit out to add can lights in the living room and a circuit out to add can lights here in the kitchen ceiling. So a lot to do. We're also going to clean up all these old wires that are dangling around. They had like a ceiling fan here. That doesn't make much sense in the kitchen, so we get rid of that. Just generally cleaning up. And then there's a wire here, kind of sticking out. There's a wire there that goes to the outlets in the kitchen, or in the living room. And there's a wire over here that feeds the outlets on the west side of the house. Those are all going to get junction boxes and reconnected. Part of the fun of rewiring and working on electric in an old house is you have to figure out what breaker runs what. And so I figured out that this 20 amp breaker right here runs basically half of the house. So the wire comes out of there on the hot, goes out the bottom of the box. You pick it up here where it hits this snarly mess there, goes through this stud and into the back of this light switch. Now, that's weird because it goes in the back of a light switch, and I figured these two are running up and they're powering a light that used to be there, a light over there, and then they go into the laundry room over there and power that light. I thought that was it, but not so. Once I got up in the attic above this box, which was holding a light, it's being used as this massive junction box that then takes wires and sends them all the way through both bedrooms on that side of the house, through the bathroom, through that bedroom. I mean, it's crazy. So that's all running. And it's also running on 14 gauge wire, which isn't really proper, especially on a 20 amp breaker. That means the wires can overheat before the breaker trips, causing a fire. So that's a risk. So what I'm going to do is I'm going to remove the hot from here, take that old nasty piece of wire out, put it onto a 15 amp breaker and run it down out of the bottom into the back of this box. So it's going to follow out of here into the back of this box, and then I'm going to put a 3-gang box on here, so there'll be the 2 light switches that continue to run what's over there, and then a third one which will hold a GFCI outlet. So all the power is going to flow through that GFCI, giving protection to that half of the house, because right now it's on a 2-wire system. You can't protect it without ground other than putting a GFCI in. So this will give the whole side of the house protection. If anything faults out, it'll trip this GFCI. First thing is going to be to use the drill with this auger bit to clear out spaces in the wood for the wires to run through. I figure this is a good opportunity to show the 2 different kind of electric boxes that you can work with. Now, there are lots of different varieties of electric box, but the 2 main components are new work boxes and old work boxes. New work boxes are designed to be nailed directly into exposed studs, so if you are opening up walls or building new construction, use a new work box. And they have these little tabs here, you kind of see them on the side, that show how far you need to sit proud of the stud so that when the drywall goes on, it sits flush with that front edge. To contrast that, this is an old work box, and it's used when you have existing drywall. Don't mind that over there. When you have existing drywall and you want to put a box somewhere on that drywall, and you can't nail it into a stud. So this box looks like this, and it has these little flappy guys so that when I fold them down, push it into an opening like this one right here, I'll push it in and then I'll screw that screw with a screwdriver or my impact. It'll open that up, and then this will draw in and tighten against the back of the drywall. So I'm going to show you how that looks. This is very useful if you just want to add outlets Or if you have a situation right here where I don't want to pull this drywall off, it would just be extra work. So I can add this in to put a switch up here and an outlet down there. Okay, the way this works is very simple. I've got the 2 wires that I've run in the wall through the back knockouts of the box. So now I can pull them tight, fold the flaps down, and push the box into the opening. The wires are coming out, so I'm going to center it up. Take my impact, tighten this down, and it's pulling that flap against the back of the drywall. There you go. Box is in securely, wires are out and ready to go. A quick video walkthrough of all the new circuits. I'm just going to walk and talk. I haven't made much plans for this, so we'll start here at the panel, and then we're going to trace up and over. And the first circuit is going to run everything on this wall, essentially. So there's a vent hood wire that comes off of that circuit. The wire comes down, double outlet there, down, over, up, and feeds this switch and that outlet there. At the switch, we go to 14 gauge, up, over through the ceiling, out to that. It's going to be the dining light area. Okay, that's one circuit. Next circuit, box up, just straight up and over and down for a dedicated fridge circuit. Okay, back to the box, up and over here, comes down. And we've got a box here that will feed power into this half wall. So this outlet here will have a dishwasher plug, possibly a garbage disposal in the future. And then on the other side of the wall, there's one here and one there being fed off of that circuit. Okay. This also will provide power up, over, and into a junction box on the other side of the beam that goes across the ceiling and feeds that box and the outlets along these walls. Okay, there was an old wire up in the ceiling that was already there, didn't want to have to mess with that. Okay, back here now the lighting circuit. So that's this white wire that's dangling. I still need to get a tension relief piece to put it into the box. So it goes up and over and brings power into this mess of wires. So then we're going to have a couple of 14-3. So right here, these go up across the ceiling and down to that box over there. And the reason for that is we're going to have a 3-way switch with there and here. So when you come in the front door, click, you can turn on the lights that will be across this in the living room. Click, you can turn on lights that will be here on the kitchen ceiling. And then if you're leaving out the back door, or if you're just in the kitchen, you can also control those lights here via 3-way switch between there and there. Wire in the kitchen ceiling to run those lights. There's a wire sitting on top of the drywall there that is going to feed those lights. Here's the 2 overhead lights that the 3rd gang box will have a light switch to control these 2. Okay, back to the box. We went under the house. This wire was existing. There's a circuit that was running the fridge over here, but I've redirected that. I put a junction box under the house in the crawl space, runs that direction and feeds the sump pump on a dedicated circuit. Here, out of the box, you see this yellow wire. Goes down the crawl space, under the kitchen floor, up here, using pre-existing holes, and feeds that outlet, which is going to have a microwave that sits right here under the kitchen countertop. Microwave always on a dedicated circuit. What else? Okay, then there's this messy circuit here. So this one comes off, all new wiring. These were all the old, ugly cloth sheath Romex, so they go up. The whites feed One goes up and over here, which will feed an external light for the back porch. The other goes up over here and feeds the light for the pantry and another light for the laundry room. Then we got power coming in again. These sets, so one of these chases up and over into a junction box over there that was put together by the previous homeowner that feeds all the outlets in the bedrooms, the 2 bedrooms, and the bathroom. So there's a big junction box. I didn't want to rerun wires through the closed up wall, so I just tied into that with new wire. And fortunately, when they rewired, they added Romex that has a ground wire. So everything is now grounded. That's excellent. Up and over, you can kind of see this is dangling here. That's going to get connected to this one, this wire that feeds the washing machine outlet. And then all of those feed through a GFCI outlet here to provide additional protection for everything downstream, including the bathroom. So this is the GFCI that's going to trip that almost that half of the house. I believe that is everything. It's been a lot of cleaning up old nasty wiring. Small update for those with keen eyes. I have swapped out the 14 gauge wire for a 12 gauge on this circuit. It is the switch leg. It'll never have more than a single amp from an LED bulb. However, code requires that if I have a 20 amp breaker, all the wires on that circuit are 12 gauge. So that has been corrected. If you were itching to make that comment, go ahead and write it anyway. It helps the algorithm. And for those of you who may have been screaming about this circuit here, where it comes in 12 and goes out on switches, again, those are going to be LED bulbs with very little to no amperage draw. But that's on a 15 amp breaker, so not to worry. I did mix the wire gauges, but 15 amp is sufficient for 14 gauge wire. If you made it this far, please consider subscribing to the channel. I'll be doing videos on the entire renovation process for this home. Thanks for watching.